Yeah, so today I'm here trying to convince you that the Wrinkle Ridge Dorsum Circle, which you can see in the upper left-hand corner from this L-Rock oblique image, that it formed post some of the youngest lava flows in Mare Imbrium. So just to give you some context, wrinkle ridges are large landforms. We find these also on Mercury and Mars, and they are formed by compressional faulting and folding. Now, the main structure of them is that you have, if you look at the profiles in the lower right-hand corner, wrinkle ridges usually have this broad arch and then this ridge, this kind of peak on top. How the fault manifests underneath these wrinkle ridges, we're still exploring that here from Tom Waters' recent paper. Some of these faults possibly just go deep into the Mare, or maybe some of them are listric. It's also been suggested that some of these wrinkle ridges possibly have back thrust faults as well. But it's not what I'm here to talk about today. So there we go. Okay, so to give you some context, so Dorsum Circle is where that yellow star is. It's in the southwestern portion of Mare Imbrium. So Mare Imbrium formed about 3.9 billion years ago, and most of the basalts that were emplaced inside Imbrium were placed there about 3.6 to 3.3 billion years ago. And there are hundreds of wrinkle ridges that lie inside Imbrium. You can't really see in this image, they're in blue. This is from you et al. 2017 paper, who actually applied the buffer crater count technique. So that is a crater counting method for specifically linear landforms, and you can derive an age for that linear landform independent from the surface that they are cross-cutting. And so they were able to derive an age for the ridges in Imbrium, and they got 3.1 billion years. And so what's interesting about the method, how they applied the buffer crater count method, is that they did not break them down individually. They actually just clumped all the ridges together. And so, like I mentioned earlier, there are these young flows of Mare Imbrium. There we go. Shown here in that southwestern portion of Mare Imbrium. Shaber from 1973 suggested that they're 3.1 to up to billion years old. But Harry Hiesinger did some crater counts and suggested that maybe one of those flows are Imbrian age. So these basalts are high in titanium, and they likely came in phases. Most researchers have suggested 3 phases, 2 early and 1 late. And the source of them is in the Euler area, Euler crater, which is seen down here. And Dorsum Circle, just to give you some context, is about here. And it makes sense of why those lava flows are where they at, because this is a focal point of the horizontal extensional stresses due to basin loading. And so these flows are probably sourced from a series of crust penetrating dikes. So this is a really beautiful composite image of 4 apollometric images from Apollo 15. You can see Dorsum Circle right here, this wrinkle ridge, but you can see the finger-like lava flows just cross-cutting and just making their way into central Mare Imbrium. And so Brian first suggested that the lava flows cross-cut over the wrinkle ridges, then pooled, and then went over the wrinkle ridges and carried on into Mare Imbrium. So you can kind of see in the image a little bit the flow fronts right here. But I kind of argue about that because the flow fronts are only, the maximum height of these flow fronts are 40 meters. They're typically about 15 to 20 meters, whereas the wrinkle ridges in this area are 100 meters plus. So you would have to have a lot of energy to go over the wrinkle ridges. And it's really only this location that we see some type of channeling. And so Shaver et al. 1975 did this beautiful map of the individual lava flows, and then also mapped out where the wrinkle ridges are. And from what, if you can maybe see, is that you see these lava flows just continue on, but they don't go around any of the wrinkle ridges, like if they were existing prior to the flows. So here's a Kaguya image with the SLDM on top of it. And with the white arrows, you can see, again, the flow fronts, and they start in the Euler source area, and they just continue in a northeastern direction. And you can see that they just do not evade that wrinkle ridge at all. They evade this kind of kapuka right here, but otherwise by Dorsum Zirkel, they don't evade whatsoever. And so here's a nice LROC image. There we go. So the yellow arrows point out the wrinkle ridge, and you can see how this young lava flow just goes on top. So what happened is that the lava flow came through, and then the wrinkle ridge essentially uplifted that flow. And so the reason why this is interesting is that some of us really want to go back and break down the ages for the wrinkle ridges. So the You et al. Paper does not resolve the diversity of the wrinkle ridge formations. It's just kind of representing of an average formation time. So this is kind of a first step in that direction of looking at Dorsum Zirkel, seeing that most likely it formed after 3 billion years. And so the main point I want you to take right now is to that the major wrinkle ridges likely had a longer formation time long after Mare emplacement, that it wasn't as short-lived or long time ago. So thank you.